Hello and welcome everyone. Thank you for joining us today for our webinar titled Towards Responsible AI. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Benjamin Cox is a current MBA candidate at the University of Chicago Booth School of Business, majoring in business analytics and econometrics and statistics. Prior to joining H2O.ai, he led Ernst & Young's first artificial intelligence incubator with an industry focus on financial crimes and has worked as a graduate intern data scientist at Nike. He's helping run Explainable AI and AI transformation, as well as supporting Patrick Hall and Navdeep Gill as a contributing author on their recent NeurIPS paper titled Proposed Guidelines for the Responsible Use of Explainable Machine Learning. He's also volunteered as a business sustainability advisor to WildMe, and he has held positions at NTT Data, UBS, and Citi. He graduated from the University of Charleston with a BS in economics and finance. Now, Patrick Hall is a senior director for data science products at H2O.ai, where he focuses mainly on model interpretability. Patrick is also currently an adjunct professor in the Department of Decision Sciences at George Washington University, where he teaches graduate classes in data mining and machine learning. Prior to joining H2O, Patrick held global customer-facing roles and R&D research roles at SAS Institute. He holds multiple patents in automated market segmentation using clustering and deep neural networks. Patrick was the 11th person worldwide to become a Cloudera certified data scientist. He studied computational chemistry at the University of Illinois before graduating from the Institute for Advanced Analytics at North Carolina State University. Now, before I hand it over to Ben and Patrick, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. And without further ado, I'd like to hand it over to Ben.
Awesome. Really appreciate the introduction, and thanks everybody for joining. So today we're going to walk through about 20 slides, and they cover a range of domains in the responsibility, the AI, the transformation, the trust space. We largely just kind of want to paint a picture of our current point of view on responsible AI, explainable AI, what does this kind of mean for companies, and how to start thinking about these problems. So this is sort of the agenda we have today. We're going to do some terminology. We're going to talk about explainability, risk, trust, and a various array of other things. And then we're going to kind of talk about how that boils into the tools that we actually use here at H2O. So kind of getting into it, like a good quote to start with is really Stephen Hawking. Success in creating AI would be the biggest event in human history. Unfortunately, it might also be the last unless we learn how to avoid the risks. Now, I'm not one for grandiose statements on, Terminator-style views on AI or anything like that, but I think it is really important for us to understand as firms, individuals, companies, the risk you take on when you start to employ automated machine learning, automated decision-making, knowledge automation in general. Like, it's very important for us to understand what that means, and it's not just a function of accuracy, it's a function of risk and trust. So one thing that I like to start with too is I'm sure most of the people watching have seen at least one of these examples. There's no lack of artificial intelligence fail cases that we see today in the industry. Everything from trading algorithms to natural language processing to chatbots to credit card and loan decision models. The list really goes on and on. But one thing that we want to kind of draw attention to here, and something that we think about a lot over at H2O, is it's very easy for us to, in the media and as observers, to say, oh, that's an algorithm problem, or that's a machine learning problem. But the thing about these models is they use training data. So a lot of these things that you see in front of you are about the data that was ingested to ultimately build the model to make a decision or to talk to a human or to trade a certain currency. So one thing that we want to keep top of mind as we start to talk about responsible machine learning, explainable AI, is really the idea of garbage in, garbage out. You're only as good as your data. And if you're training on a data set with historical biases, those are going to be perpetuated into the end result of your predictions and your models. Now, there's some ways around it. That's something that we kind of want to talk to. But it's just something that's always worth considering, because if you don't go into these problems thinking about this, you end up just perpetuating historical discrimination that has existed over time. And that's exactly what we want to avoid. So the other thing about this space is that, while we get really, really excited about, seeing a CAGR of 36 year over year over the next decade, and all of the potential high value use cases and all of the big consulting firms and companies that are getting into this, it's important to understand, the trust around this industry, and it's not great. This timeline that you can see here is really just between 2017 and 2018, and it highlights all of the essentially trust-breaking events that have occurred that have given, some less than great confidence in the industry. And it's important to think about as we go forward as practitioners, like, what's our responsibility when we start to deploy AI models or machine learning models in production? Because if you don't really think about these things, what's sound, what's valid, what do we run through model risk management, you're kind of doomed to repeat these things. So there's a lot going on in this area and moves so fast, and we work so hard to innovate so effectively, that it's important to stop and take a beat and think about all of the things that we've seen in industry and how we can avoid future situations like these going forward. So that's, my little call to action, but now we can kind of get into it. So one of the reasons we thought it'd be really important to do this is, H2O, our team, and a bunch of other companies are all barreling forward with academic research, thought leadership, symposiums, summits, debates, talking about what are the key terminologies and pieces that we need to consider. And really, there's no correct answer, right? Like, we think we've got it down to primarily correct answers, but one thing I want to say right out the gate is that this is an evolving area, and we welcome any feedback. If you see a definition here that you have like a radical opposition to, or you think could just use a couple bullets, please reach out to us. We're very communicative. We're really just looking for best practices. Like, at the end of the day, our mission is democratize AI, and we want to do that through our thought leadership, through our research, and through our kind of opinions on these things. So with that being said, we really view responsible AI or responsibility as the aggregate of a bunch of different things. There's a bunch of different areas that are really hot topics at this point, but we see responsible AI as kind of the parent bucket that combines all of these considerations as you start to deploy your AI. So when we talk about explainable AI within H2O, that purely means your ability to analyze a machine learning model after it has been developed. So what kind of post hoc analysis can you run on these models? Interpretable machine learning is largely talking about how transparent model architectures, and increasing how intuitive and understandable machine learning models can be. By nature, not all of these models can be as easily understood as one another. A complex ensemble model is just not as easy as a single decision tree, right? So it's understanding the framework that makes something more or less easy to understand. Ethical AI is one that gets talked about a lot, and we think is like super, super important. It's really talking about sociological fairness. When we talk about fair lending and who's getting loans, you really can't use certain features like, what's somebody's ethnicity, what's their gender. Like, these things are important, and we want to make sure that as you start to deploy AI in your company, that you aren't creating a disparate impact against a certain protected class or person that really shouldn't be weighted in this type of model. Secure AI is one area that we're focusing on a lot as well. I think this is largely much, much newer, but we're trying to be on the bleeding edge of this. It's talking about debugging and deploying machine learning models with similar countermeasures against insider and cyber threats as would be seen in traditional software. To understand this, we've gotten very good at understanding cybersecurity in software, but as AI and machine learning developed, nobody really thought about, can my model be hacked? And the thing is yes, it can. Can my data be hacked? Yes, it can. So these are considerations that are not top of mind for everyone, but are going to become increasingly relevant as we get further down the road. And it's important to start having this in the back of your mind as you start to scale into some of this technology. Human-centered ML, that's a really core area. I think a lot of people get excited about machine learning and AI, talking about, oh, we're going to set this model into production, and then we're just going to walk away and forget about it. There's a really important point talking about human centricity with machine learning and thinking about, what are the user interactions can you have with the AI and ML systems? Can you appeal the process? Can you tinker with a variable? Can you pause? There's a lot of different things that one might want to be able to do as your model is running versus just having a fully autonomous machine, right? I think there's a level of human intervention that's desired and is actually should be considered as you start to go forward. So our goal here is really to just explain things to you. You'll hear the term XAI a lot, but we really just want to explain and give you guys a better understanding of what the bigger picture looks like here. So I won't go through the depth of reading this long definition, but it's really about proving the work, right? I think one thing that happened in industry is deep learning models, got really turbocharged by a couple of computational advantages, cloud computing, GPU computing, and some of the newer model methodologies that came out, and they got really, really popular. But we never really stopped to think about, how much can we unpack this model and how much can we analyze why it made the decision that it did? And it gets really confusing too when you're trying to explain to some end user, whether it's a regulator or a person who applied for a loan, that the reason a decision was made had to do with one of several hundred epochs or neurons or nodes that made up a deep learning model, right? So we want to push this message of you should want to be able to understand your machine learning and AI models. Accuracy is critical, but a 99% accuracy in sample with no understanding is pretty dangerous, right? So we want to kind of go forward and give you some understanding. So we started with explainability. I think that's where a lot of us came to, where we talked about, okay, there's a lot of complex models in this space, and we're not doing a good job of really unpacking them and explaining them and walking through them or being able to do any of these things. So it started with explainability. We started looking at our ability as data science practitioners or data science managers, at our ability to be able to quantify why decisions were made and think about really what that implies from a business context. But this kind of grew, right? It's not just a consideration of thinking about, what was the feature importance here? What kind of feature engineering did we do? Does that cluster make sense? It's really about, once you get away from the models, there's also a people, process, and technology aspect to this. Did you start this project with a reasonable scope? Do you actually know what your why is that you're trying to predict? Are you asking questions correctly? So responsibility has come up from a variety of areas. Compliance is one of them. Are you in compliance? Do you have a human intervention point in a machine learning model? Is there appeal process? Basically, we want to give this idea that there's more steps than just your typical model validation phase. And it goes beyond just what software did you use to deploy it? Did you use H2O? Did you use Python? But it goes into a people aspect. Did you monitor these models? Do you have the right team around it? Did you review it for feasibility? Did you think about what the data quality, the data drift, the data texture is? There's a lot of things that go into this ecosystem, and what we're trying to stress and push forward is this idea that, this area is moving very fast, and as we'll get into later, it's not just about sacrificing accuracy for responsibility or sacrificing, a level of predictiveness for stability. When you start to talk about deploying these models in production, it's really important for you to be able to understand all of these levers to know that the decision that you're making is actually rooted in kind of common sense, business knowledge, reasonable statistical soundness, and that's the kind of thing that we want to talk about today. So it gets bigger, right? I think one of the things that happens, if you go to talk to a company and you say, look, they want to engage with AI, they see all these successful use cases in industry, they really want to know, how do I do it, and why don't we have it yet? And the problem is that most of them don't think about the true scale of what they're taking on. The most common things that you will hear about the risks of AI are, we don't have the talent, or what is the regulatory risk, or what is the PR fiasco if something goes wrong, like those headlines that I showed you at the start of the deck. The problem is with almost all new technology is there's a big iceberg underbelly to that, right? You don't talk about machine learning technical debt. You don't really talk about what are the automation concerns as you start to automate specific functions, roles, titles. what do you think about that as a company? How do you start to phase into that transition? What do you do with those employees? They don't think about ethics and bias consideration. They don't think about historical discrimination, part of their prediction process, via human user getting perpetuated by a model. They don't think about risk management. It's very easy for a non-savvy user to see, 99% accuracy and not really understand, out of sample, it might be significantly worse. So cybersecurity, this is an area I got into as well, where I talked about not enough people are considering the aspects of what if your model gets hacked? What if somebody knows the way that you're predicting your models and can kind of game the system? It's very important because these areas are becoming super, super costly. And, when you are a firm looking to go out and kind of segue into artificial intelligence, there's a lot you need to consider. And that's our goal, really, is to present people with the full docket of things that they need to think about as they start to look to embrace this kind of technology. So another piece of this, and this is a part that really gets misunderstood, a lot of people and companies think that it becomes a game of how much alpha or predictiveness or accuracy are we going to sacrifice in order to have a more stable or more regulatory compliant model. And that's not a great way to think about it, right? Yes, you might find that in sample you have this deep learning model with a million hidden layers that predicts super well, and then if you switch to a light GBM, you lose a percentage point or two. But the thing is when you talk about being a business that's scaling into AI, there's often what appears to be a conflict of interest, but it's actually two sides of the same coin. You really, from the business leader, executive, and managerial offices, they want to know the risk, right? But for data scientists, you really want to understand, how much you can trust the model. And the thing is these both go hand in hand, right? Knowing when to trust your AI allows you to decrease risk significantly. And being able to correctly understand and quantify risk increases trust, right? So this is a snowball effect. The better you do at either of these things begets the other. And really, as a firm or practitioner, you want to lean towards the best predictions, but you should also be doing it with the context of not overanalyzing a certain signal. So you really should be thinking about, is this the most stable model? Are we capturing all of the signal in an intelligent way and we're not over-engineering a result just for the sake of complexity or just for the sake of like a 0.01 increase of accuracy, right? So this is something we really impress upon firms and companies to think about. These goals are the same, right? You really want to understand risk and trust. And that's the thing when you get into the prediction business that you really need to have a handle on as you start to go forward.
Hey, Ben.
So,
Can I add a commentary real quick?
Please jump in.
So just one point I would add here, from a technical perspective, is especially for tabular data, the kinds of data that companies have used traditionally, and I would think are probably still most widely used in terms of commercial data mining products. The perceived trade-off between accuracy and interpretability, specifically for tabular data, is basically dead. So if you're using tabular data, there's all kinds of fun new models that you can use that are directly interpretable and as accurate as traditional machine learning black boxes. And I don't want to derail the flow here, so I'm going to shut up, and I'm happy to sort of take questions about that afterwards. And yep, I'm going to shut up. Just wanted to throw that point in there. Thanks.
No, thank you so much. And I mean, there's an aside point that we just had a paper go out talking about explainable neural networks with tabular data and talking about how we're getting to a really awesome point where you don't have to make accuracy sacrifices for explainability.
At all.
And that's something, and that's something we spend countless hours on. So it's great. It's great to see results in this area that we hold so close to our hearts. So let me jump back in. This is going to be an awesome point to talk about after, and I'm all for it. So how secure is your ML strategy? And this secure maybe isn't the best word, but I think a good way to think about this is if you're a firm and you're deciding you want to scale into AI or transform with AI, what are some questions do you start to ask? What do you start to ask? And I think a lot of companies fail to think about some very basic things. These are kind of mid-level questions that you should consider, but a lot of questions drive from something as simple as, do you have data? Is the data a quality that is worth modeling on? Do you have the infrastructure to even run these machines? But something to consider, like, do you have a big data architecture? Do you collect and utilize your data efficiently? Is it confidential or is it protected, and what kind? How many data scientists do you have, if any? Is your analytics function a vertical or a horizontal? And do you have a model governance function? Many companies don't. They haven't had the need to. And do you have a center of excellence for data science, machine learning, or AI? I don't want to spend too much time here because I kind of want to keep moving forward. But I think it's important to think about, it's not as simple as just building a model and sending it out there and just reaping the rewards. It's a legitimate investment. So as you start to think about investing in this technology as a company, it's really important to accurately price what the investment will run you. And I think that's a thing that gets lost all the time is in this industry. We talk about, a model was built and it predicted better than a bunch of legal experts or something like that. But it's really important when you're starting to talk about bringing this technology as a company. How does it fit into your existing model? What does the future look like for you? What kind of technical debt are you taking on? Do you even have like a technology architecture that supports this kind of thing? And these are all functions, coming back to the core thesis here, that feed into responsibility. If you don't have any of these things that I've listed out, you're going to struggle to be truly responsible with your AI deployment, because you might not be doing it in a way that is cognizant of the people, process, technology that needs to exist or needs to be overseen in order to ensure that you're really deploying models in a safe and responsible fashion. So I'm happy to talk about any of these in depth, but I think when you start to look at things from like a people and a corporate perspective, these are some really big considerations, because these things make a world of difference in production. So, how does this come back to us? We use Driverless. It's our lifeblood. It's a phenomenal tool that we've built out, and we've really built it out around this core idea of responsibility. We started with explainability, but it's really snowballed into so much more because these areas are so critical to us and the people who use Driverless. So the things that the capabilities that we've built around this are this robust explainability toolkit. We have a human-centered focus. You can really get in there and tweak things in the model. Automating interpretability. You don't have to decide you're going to go code up 100 lines of interpretability. You can just have that presented in that dashboard created. And even a fairness, disparate impact, sensitivity analysis toolkit to start think about how are certain classes or categories of data being treated. And then even compliance resources, like fair lending is a big area for us, and it's something we keep very top of mind. So I'm going to get into the technicals a little bit. I don't want to spend too much time here. We try to keep this at a level that a C-suite person or a business user could try to understand, because once we start rattling off some of the hard technical areas, we lose some folks, and that's not what we want to do here today. We want to give you an idea of the statistical methodologies that exist out there as the latest and greatest industry-leading ways to audit, analyze, review, explain machine learning models. So this is a high-level overview of our technical toolkit of just some of the things that we bring. But I'll go through some of my favorite ones that I think I like the most and give you a little kind of layman's definition of what those sort of mean. So Disparate Impact, this is one of the favorites. This is really the tool that you're going to use to think about are men and women being treated fairly? How do we start to look at that statistically? One case that comes up is really fair lending. And if we look at factors that attributed to why someone did or did not get a loan, and if you find out their sex or their gender is a reason for that, that's a big, big problem, right? So this specific tool, Disparate Impact Analysis, really gives you the ability to kind of pull those levers and see if certain categories or classes of a feature are causing a prediction or an amount of importance in the prediction when it shouldn't be. Shapley Values, really used to define the importance of a single variable to a specific model prediction versus the variable importance at a global level, right? So statistics really started as a descriptive or looking backward era. And we want to think about when you build a machine learning model, the prediction or the feature importance of a variable, like, did you pay your bill last month, might not be as important in the specific model as it might look in the aggregate of the entire data set. So it's understanding like how different these might be. K-Lime is an explainability method that compares complex models to simpler models. The thing about this space is that most of us who got into it because we love some complexity and we love complications. And it creates this problem where, we really love to do complicated models, to do complicated solves. But to be honest, a lot of the value being driven in industry is simple models on simple use cases. And I think that goes over a lot of people's heads because you want to build a G5 jet, but that's not always where the value is being derived, or at least where you can create the most value. So assuming the prediction accuracy is the same, always lean towards the more simpler model. Surrogate decision tree, I'm sure many people have seen this before. It's really talking about the likely flows of predictions and what are the kind of variable weightings at each node of those predictions. So in this case, we use one example where it's how likely would you have been to live if you were on the Titanic? And it shows right out the gate one of the most important variables was sex or gender. And then it becomes, were you a cabin or a luxury passenger? So you can see the kind of flow through in the importance of variables and how it actually kind of amalgamates to an end decision. Partial dependence plot really used to show how much impact the prediction of a single variable has on average. You want to know how much each variable is important by itself and at the aggregate, and how much it's sort of weighting things overall in all of your predictions. So that's another way to think about features. So I want to leave it there with respect to the statistical portion, and I want to kind of do a couple minutes, and then we'll open it up to questions. I want to do a couple minutes talking about kind of how we got here, because things have moved very fast. A lot of folks don't understand how this picked up so quickly, and I don't totally know the demographic of the people who've dialed in, so I want to keep it kind of crossing the lines. So, we started with this basic statistics, and we were able to move to predictive modeling. Then we got machine learning, artificial intelligence, explainability, and responsibility. So the way to kind of think about this, and this is just like a brief history lesson for everyone, is the math for AI has existed for decades at this point. It's been around, but for the longest time there was a data restriction and a computational restriction. So we could know the math of an autoencoder in the 60s, but there was no massive data set to really put a learning algorithm to work. We got this kind of boom in statistics where we learned a lot of great explanatory statistical models, and we got good at kind of analytics that were looking backwards. So if we want to see forecasting trends or sales trends, we got pretty good at creating nice business intelligence of looking backwards. And then we got to the predictive modeling phase where we learned, with some statistical methods, logistic regressions, this and that, ARIMA models, we can predict forward with some degree of accuracy. And as I'm sure most people have seen or have been shared at least once, the introduction to statistical learning, we learned that with bigger data and bigger computational horsepower, which was kind of ushered in from some GPU computing inventions, some cloud computing features, and a lot more data being produced over the last 2-3 decades, we realized that we can really do some nice machine learning where we create these models that can learn over time, that can be pretty unbiased and can get pretty intelligent. Then you have this kind of AI world, which the definition to many is still very up in the air. But one of the areas that really took off was our ability to deal with unstructured data. And a lot of this was from the deep learning neural network era, doing some computer vision, some reinforcement learning, some natural language processing. And that was really awesome. We had a lot of data, we had a lot of computational power, and we were able to get there. So Then we get to the step 5, where we're talking about explainability. We spent a lot of time building all these great models with great amounts of accuracy, but it becomes clear, very quickly that without understanding or being able to explain why your models made decisions, it's a big issue. In finance, it became a legal requirement and a regulatory requirement for them to do that. So they became very first in class. But, companies started to realize that even if they weren't, dealing with regulatory concerns, say like a retailer, if they mispredict or if they fail to predict because they don't really understand their model, they might massively overproduce a specific product or massively underproduce a specific product and create a lot of economic loss for themselves. So there's a real financial toll to getting this wrong. And, the appeal of these super high accuracy in-sample models that don't really think about what does the future look like for this data or our customers is pretty dangerous, because you start chasing this, historical, view of your data. But the problem is data changes, your customer changes, and you need to really be able to think about how things are going to look in the future and be as unbiased as possible. Or, I'll use unbiased for now. And then responsibility. I think responsibility is where area we are at now. I think we realize that a lot of companies in their day-to-day operations create a certain amount of systemic risk, right? So I think one way to consider responsibility is, if you think about big financial institutions that have trillions of dollars of books, you'll realize that if they get their models wrong, the economic waves the ripple effect can be disastrous. I think you're all familiar with one or two use cases where this might have occurred, but it's important to think about the ramifications of not thinking through your AI deployment. And I think responsibility has so many legs to it. Understanding, is your data hackable? Like, are you a hub of data that you're just ingesting all of this customer data and you're not thinking about the security of the model? Can your model be, hacked? It's super critical. So beyond just compliance, beyond just security, beyond just fairness, it's about thinking about this more holistically. Like, are you creating an infrastructure where this, one, can be successful, and two, wouldn't necessarily create negative externalities around what you've done? So in the paper that we presented to NeurIPS last year, we had a much more in-depth workflow. And I think in our recent paper, there's a much more in-depth workflow as well. But that's not what I'm in the business of doing here today. I'm in the business of giving you as simplified down process as possible for how this truly should look. Now, I don't know how familiar folks are with model development, lifecycle management, but the way to think about it, at least in the most simple steps, are you're going to have your data loading, prep, exploratory data analysis, and feature engineering phase, where you're really starting to get under the hood, maybe like tinkering around, seeing what has signal, what maybe has anomalies, that kind of thing. Then you'll actually, that tends to be the most time consuming, albeit. Then you'll have your model training and assessment, where you'll start to throw a bunch of models at it and see what maybe has some true predictiveness or might have some viability. Then you're going to want to review for explainability, interpretability, and fairness. That's a really responsibility bubble. And the thing is this is an iterative process. There's not, you're never done. And that's not a great thing to say, but it's something important to consider. This is an ongoing thing, and you need to be cognizant, because your data will change, your customers will change, the accuracy of your models will change. It's not 95% accuracy, send it out, and it'll always stay that way. That's just not how it works. So it's important to stop here and also highlight that these 3 steps that I just described are all vulnerable to human and data biasy. So we like to think that, it's only the data that's biased, or the modeler is biased, or the algorithm's biased. At every single one of these steps, there could be a human error that introduces bias, there could be a data error that introduces bias, and there could be a modeling perspective that introduces bias. And I don't like to use bias because there's a statistical meaning to it and it has its own relevance, but it's what people resonate with the most. But I will say, at every one of these steps, as you are a practitioner or a manager out in the field, it's important to stop and take a breath and think about, okay, what was our workflow as we went through this? And did we do anything that might be kind of fishy, in terms of approaching this from a purely agnostic viewpoint. A lot of problems in machine learning and AI deployments, you come in with a kind of conclusion that you want to see, and you kind of massage everything in the right direction to kind of confirm that conclusion, and that's kind of dangerous. So I'll say you have these 3 steps, and for each explainability, interpretability, and fairness piece, that seems like it fails, or it seems like you're including a variable that you shouldn't, or it seems like something is getting weighted in a wacky or wonky way. Run it back through the model, try dropping it, try tinkering with it. At least Driverless, we do a really good job of giving you a toolkit where you can adjust certain variable averages, means, specific inputs to really tinker around and see what might have moved a certain customer over a threshold for a yes or a no prediction. It's really about experimentation to really better understand what's going on. And then there's the model production environment where you actually have this model out there in production, creating value for you, your company, your clients or whoever. And it's important that it doesn't end there. This is an iterative process. It's your responsibility when you have these automated intelligence tools to consistently rework and review and monitor. And, banking institutions have so many teams around this, model risk management, model operations, model validation. A lot of companies that aren't regulatory constrained won't think about this. But if you're deploying AI, ML in prod, you should really think about having these resources to really consider what's going on as this model kind of iterates through every prediction, whether it's predicting a loan, yes or no, or how many shoes we should make to send to a big box retailer, or these kinds of things. It's critical to understand what's happening with the data, what's happening with the model, what are the kind of insights that are being drawn from it. And with that, I think...
Hey, real quick.
Sure.
Sorry. Ben and I aren't in the same place, so I can't see if I'm interrupting him or not. But I would just add very, very quickly, while right now it may be mostly financial services and healthcare and insurance, some degree, education that are, experiencing a regulatory burden here, I checked this morning, and I think there's 4 states looking at passing either data or AI-specific regulations. There's an act being considered in Congress, multiple international, multiple other countries have either proposed or enacted AI-specific guidelines. So just because you're not regulated now doesn't mean you won't be regulated in the future. And of course, if you're ready for that, it makes the compliance burden much lower. So I'll just throw that in and shut up.
Yeah, I'll piggyback off of that. So one, there's this classic fallacy or misguided idea that if we're not regulated now, we never will be. And I think, personal opinion, no views of any H2O or anybody else. This is just my opinion. To think that you could be deploying AI or machine learning via your company and not be facing any sort of regulatory scrutiny at any time in the next 5 to 10 years, I think is kind of crazy. But I would also say to think about, if you watch how financial services firms respond to regulation, it's not that they find out a regulation is going to go into effect January 1st, 2021, and then that's when they start to solution the problem. They start immediately when they find out that it even might go into existence, and they start immediately figuring out what's the business continuity plan for when that occurs. So if you're a company and you're invested in this space, it would behoove you to start to think about these problems and start to work through them, because having to stop all production models when a new regulation comes out is likely not an option. So being on the front side of this is great. But then I'll just kind of flip it back to my other point that I wanted to drill home too, is this isn't just about compliance or passing regulatory exams. The more you get aligned with this kind of thinking and how you deploy, manage, oversee, review, deploy again models, will be better for your business at the aggregate, because you have a much more stable, durable modeling system versus something that, the minute an anomaly comes into the data population, it completely throws everything off. This puts you in a position to be way more resilient, to data drift, economic shocks, anything like that. And I think that's an important thing to consider just from a best practices of statistics viewpoint.
Yeah, I think that sounds about right to me.
Thank you. So that's all. I think, Patrick, you said you might going to open it up to questions, I think.
Yeah, I think this is the perfect time. Sorry, which Patrick? Go ahead, Patrick Hall.
Nope, just saying yes. Let's see if anybody has questions.
Cool. So I am seeing one for the moment here in the questions tab. So everybody on the line, please start entering your questions. We'll get to most of them with time permitting. The first question is explainable AI the ability to know why an ML system made the decision it did?
Roughly, yes. There are some caveats. I would say it's the safest way to think of it. Explainable AI is like a summary of a prediction that a very complex model made. And so, you know, a summary can only be so descriptive until it just turns into the thing that it's describing. And so its explanations are somewhat approximate in most cases. And so I think that's the caveat. Like that's the caveat, right? Like they're not bulletproof in every scenario and maybe not in many scenarios. But I think they're a very, very helpful summarization tool for the decisions that an ML system makes. So roughly yes, with some caveats.
Great. Ben, anything to add, or should we go on to the next question?
Yeah, I think that's a great answer, and I think I'll always caveat this with, like, you know, we've come up with these definitions as we see them. This is a fluid space, so it might change over time, or like there might be a new consensus in the industry. So largely what we want to do too is, you know, with some of these communications, some of these talks, and some of these you know, outreach or thought leadership pieces that we do, is get feedback from folks. And if you think we're wrong, like, reach out to us or let us know, because we're working through this as well, and this industry is moving, specifically explainability responsibility is moving so fast. We want to make sure we're on the bleeding edge, but we also want to make sure the industry is coming up with the best thought leadership possible. Because I think, you know, my soapbox is that all of us as data science practitioners should be jointly invested in creating trust in this industry, and also creating security in this industry around how do we do this in a safe way, and how do we get people to trust us to do things with this really awesome, you know, technology that we have at our hands.
Great. So the next question that I'm seeing here is, do you see a connection between transparency of machine learning processes and a decrease in financial or operational risk?
So I'll jump into that. I think Patrick might have a follow-up. You know, I don't think I have data that I can show you or that I can, like, necessarily point to, but I can tell you generally, when there's more transparency across, for instance, one big one in banking is data lineage. Like, how did data originate and where did it go through and how did it end up to the endpoint where it got consumed for a model? The more simple that linkage is and more transparent that is, the better results you tend to see and the less risk you seem to take on. I can't necessarily reference examples here because it's very confidential type stuff, but I would say generally the more transparent and streamlined a process is, and understanding the links that are in the system in terms of oversight, management, and, like, you know, monitoring, you see a lot more resilient business units that decreases, like, a fundamental or operational risk. Great.
Okay, now the next question we're seeing is, what is the best way to evangelize these concepts and influence organizational culture?
Oh, I have an answer. And Ben,
Go ahead.
Ben is probably better at this than I am, but this is my answer, okay? it's all about risk mitigation. It's not about politics. I mean, it can be, of course. It can be about a lot of different things. But I think that the best way to evangelize this to businesses is that this is just about risk mitigation, right? AI or machine learning is no different than something like aviation or nuclear power. It has a good side and it has a dangerous side, and the way to get the most out of it is with risk mitigation. And I just think that's a very, very simple argument that very few people very few people who are aiming to use machine learning to make money would have a problem with. So I think you can take some of the kind of like, if the socially charged aspects of this are unappealing to you, which I think they are to some people, I think it's very straightforward to just think of it in terms of risk mitigation. We're just dealing with a powerful technology that needs risk mitigation around it, and it's very straightforward.
Yeah, so I'll use an example that's like very close to mind. One way I've been ranting and raving about this at every company I've worked at over the last couple of years, because I think it's profoundly important. I think one example that I use constantly is there's a few examples in finance of like flash crashes that have existed. I think it was like May 6th, 2010, flash crash existed where a bunch of different models pinged up against each other and created this monster downswing in a fraction of a second that really shocked like the financial system. I think it's important to give some kind of use cases to show like, hey, if we don't actually have a full 100% understanding of what's going on or what we have in motion right now, there's a serious risk. And yeah, that's, we're talking about, algorithmic trading companies, going 100 million trades a minute, but it's important to think about how quickly things can spiral. And I think additionally, one way on the social side of it, if you think about every scandal that has occurred socially at a company, whether it's, a big technology firm or a big bank, and like maybe some less than savory practices or less than ethical practices, it's important to bang the table and say, look, like if we're going to deploy these models that use historical data to predict the future, it's important that we know that the data that we're bringing into this is not perpetuating that bias or is not creating like, signal from previous poor behavior. Because that's how this all works at the end of the day, right? So it's about creating like a very new wave in predicting that like kind of forgets about some less than ideal behaviors in the past. So Go ahead.
I just want to go on. I just want to be on the record as agreeing with you emphatically on that point. That's all.
Yeah, no. We talk about this all the time between us. And I think one thing that people will always struggle with is if you're at a company that isn't really ready for a transformation, whether it's AI, digital, data, or what have you, it's always going to be tough. Like you're always going to be the person banging the table and saying, look, I know there's a ton of value here. I know it's kind of a big investment. I know when I say create a data culture, this might not fit with you too great. But it's important to understand, there's this really great McKinsey chart that was put out where they said, 13 trillion of value will be created over the next decade or something by AI. And then there's another piece to the chart that shows firms that are early adopters to AI and machine learning will see this amount of value, gained or rewarded. And then this group that are laggards in AI, ML, analytics, data science are going to lose this much % of their business. And I think that's like a critically important chart, because if you just think about like every day that you wait to start addressing these like very worldly problems, you're kind of putting yourself at like a significant disadvantage. So I always frame it from a perspective of, look, like this isn't a matter of yes or no. It's just, it's not a matter of if, it's a matter of when. So like we need to get on it. We need to think about like the real considerations, but it's a hard conversation.
Excellent. This next one is a little bit long, so let me get through all of it. It seems to be a two-parter. Can all models be explained, or what is the most general class of explainable models? What do you need to know about the training data, and what do you need to know about the algorithm by which the data or by which the model was produced? It seems that explainable AI could alert you to that your training set is wrong or even biased when, and perhaps especially when, the accuracy rate is high. That was a mouthful. Do you want me to repeat any of that?
I feel like you're all over this, Patrick. Okay, well, if not, I can jump in and tackle this.
I was talking on mute. I'm sorry.
Go ahead.
Okay. And I said, I'm only all over it because I've been doing this for like 4 years. So I think the key is to mix interpretable models, and there's all kinds of interpretable models. So we might start with something as simple as just like a few if-then rules, which a lot of things that people call AI and machine learning are just that. And I don't want to get in an argument with anyone about that. So it could be something as few, like if their age is greater than this, if their zip code is this, that's what maybe a rule system could look like. That would probably be incredibly biased, but maybe this is for coronavirus or something like that, right? Not for a financial application. Linear models are considered to be highly interpretable. Decision trees are considered to be highly interpretable. And then there's these newer models like GA2M or explainable boosting machine. And I would definitely Google that. I would Google monotonically constrained GBM, explainable neural network. There's just all kinds of fun new interpretable models that you can try that sort of get more and more sophisticated and more accurate in many cases. I think the real key is to mix those those interpretable models with the kind of post hoc explanation analysis, and then I think you can get some real magic results and do exactly what the questioner is asking. Like if your model is transparent and then you're getting summaries for every prediction it makes, then I think you have a really good shot of finding problems in your training data, being aware that your model may be discriminatory. And so that's my prescription there. Explanations, so summaries, simple summaries of already interpretable models. And I think that's where some real magic can happen.
Yeah, I just want to, this is not like a very like deep thesis, but I just think it's a really cool time when instead of letting ethical bias, get perpetuated through your model, use a model to find the ethical bias and strip them out. Is a pretty cool time to be in the space.
Great. Seeing we have one more here, and this might be the final question.
Sure.
Can you speak to the explainable models for tabular data that you mentioned earlier?
Sure. So I just did, but I'll do it again because I was probably talking too fast. So you definitely want to Google Cynthia Rudin, Rudin. She's one of the leading researchers and just a real genius and pioneer in the space. And she basically cranks out, several of these interpretable modeling algorithms a year, it seems like these days. You definitely also want to Google GA2M or EBM, explainable boosting machine. And that comes out of Microsoft Research, I think efforts led by a very famous machine learning researcher named Rich Caruana. So then I would add in our friends at Wells Fargo have come up with a neat model, I think, called Explainable Neural Network, XNN. And then I have a favorite, which is monotonically constrained gradient boosting machines. And all of these models are meant to be more accurate than, say, those simpler linear or decision tree models, but also directly transparent.
Great. I think that'll do it for questions today. I want to thank you, Ben and Patrick, for taking the time and doing a great presentation. I'd like to say thank you to everyone who joined us as well. The presentation slides and recording will be made available on our Bright Talk channel. And have a great rest of your day.
Thank you. Thanks, everybody.
Thank you.